All right, let's dive right in. We are about to go on a journey, a kind of cosmic detective story, to tackle one of the biggest questions there is. Where did all of this, everything, come from? And our investigation, believe it or not, starts with a really simple question about the night sky.
So, here it is, our first clue. Why is the sky dark at night? I know, it sounds almost like a trick question. The obvious answer is, well, the sun went down, of course. But that's not the whole story, not even close. In fact, the real answer to this question is going to completely change how you see the entire universe.
This brings us to something called Olber's paradox, and the logic is pretty wild when you think about it. If the universe went on forever and had been around forever, then no matter where you looked in the sky, your line of sight would eventually hit a star. The whole night sky should be blazing with light, basically as bright as the surface of the sun. But it's not. It's dark. And that simple, obvious fact, the darkness, is a clue. It tells us one of our basic assumptions must be wrong. The universe isn't infinite in age and size.
So that brings us to our first major piece of evidence in solving this mystery, what I like to call the case of the runaway galaxies. You see, back in the 1920s, an astronomer named Edwin Hubble made a discovery that just turned everything on its head. Hubble figured out that the universe isn't just sitting there, static. It's actually expanding. And he found this incredible rule, which we now call Hubble's law. It's simple. The farther away a galaxy is from us, the faster it's moving away. And here's the crazy part. It's not that the galaxies are flying through space. It's that space itself is stretching, and it's carrying the galaxies along for the ride.
Let's try a quick thought experiment. Take a look at these two galaxies. Now, let's just assume they're roughly the same actual size. Which one do you think is closer to us? It's got to be the one that looks bigger, right? It's just like a car on your street looks bigger than a car a mile away. Simple enough.
Okay, so keeping that in mind, here's part 2. According to Hubble's law, which of these two galaxies is moving away from us faster? Well, it has to be the one that's farther away, the one that looks smaller in the sky. Their distance and their speed are tied together.
So how do we even know they're moving away? We can actually see it in their light. Imagine you draw a wave on a rubber band, and then you stretch that rubber band out. The wave itself gets longer, right? The exact same thing happens to light as it travels through this expanding space. Its wavelength gets stretched out, shifting it toward the red end of the spectrum, and we call that cosmological redshift. So the universe is expanding. Now, if we run that movie in reverse, it means that in the past, everything must have been smaller, denser, and a whole lot hotter. And that idea leads us directly to our second huge clue, a faint, ancient echo coming from that super hot early state.
We call it the cosmic microwave background, or the CMB. You can think of it as the leftover heat from creation itself, a kind of afterglow. And the best part is, it was discovered completely by accident in the 1960s. Two astronomers were trying to use this big radio antenna, and they kept picking up this annoying, persistent hiss. It was coming from every direction, no matter where they pointed it. Well, that hiss turned out to be the oldest light in the entire universe.
So what exactly is this light? Well, in the very early universe, everything was this incredibly hot, dense soup of charged particles. It was like a thick fog, where light just couldn't get anywhere. It would get bounced around immediately. But as the universe expanded, it cooled down, and eventually it got cool enough for protons and electrons to grab onto each other and form neutral atoms. Almost in an instant, the universe went from being opaque to transparent, and all that light that was trapped inside was suddenly set free, and it's been traveling across the cosmos ever since. The CMB is that very first light, just stretched out into microwaves after a 13.8 billion year journey.
Okay, our final clue is baked right into the universe itself. It's like finding the original recipe for the cosmos, the chemical makeup of the very first stuff that ever formed.
If you go out and you analyze the oldest matter you can possibly find, you discover this incredibly consistent mixture. By mass, it's almost exactly 75% hydrogen and 25% helium, with just tiny little pinches of anything else. Any theory about where the universe came from has to explain this very, very specific recipe. And this right here is the smoking gun. That 75-25 split isn't just something we happen to see, it is a prediction. See, the best scientific theories don't just explain what we already know, they predict things we should find. And the math behind a hot, dense, early universe predicts this exact recipe of elements. It's just incredibly powerful evidence that we're on the right path.
Okay, so let's recap our evidence. We have a dark night sky that shouldn't be dark. We have runaway galaxies all speeding away from us. We have an ancient echo of heat from the dawn of time. And we have a very specific cosmic recipe for the first elements. There is one theory, and really only one, that makes all of these clues fit together perfectly.
And that is the Big Bang Theory. Now, it's really important to get this right. This was not an explosion in space, like a bomb going off. It was the expansion of space itself from a single, unimaginably hot and dense point. And this one idea solves our whole mystery. Olber's paradox? The universe isn't infinitely old, so light from the most distant stars just hasn't had time to reach us yet. Those runaway galaxies? That's the expansion of space, still happening today. And that ancient echo? That's the leftover heat from that incredibly dense beginning.
This timeline really puts it all into perspective. It all starts with that singular beginning, 13.8 billion years ago. Then, about 400,000 years later, the universe cools enough to release that first light we now see as the CMB. A billion years or so after that, the first stars and galaxies start to form, and eventually, that long chain of events leads to us, right here, today. Those first few moments are what set the stage for absolutely everything. You start with this impossibly hot, dense state. Then, the universe goes through this period of insane, faster-than-light expansion called inflation. It went from smaller than an atom to bigger than a grapefruit in a tiny fraction of a second. As it expanded, all that pure energy started converting into the first particles of matter, thanks to E equals mc squared, and those particles began fusing to create the first atomic nuclei.
And this brings us right back to our cosmic recipe. Why did the universe stop cooking at just hydrogen and helium? Well, because it was expanding and cooling down so incredibly fast. There was only a very narrow window of time, just a few minutes, when it was hot enough for fusion to happen at all. By the time helium was stable, the universe was already too cool to forge anything heavier, like carbon or oxygen.
Now, the Big Bang Theory is one of the greatest achievements of science, but our cosmic detective story is far from over. Scientists today are tackling even deeper mysteries. What happened in the very first instant of time, before inflation? How did the very first stars and galaxies actually get started? And is there some grand, unified theory that connects all the fundamental forces of nature? The questions just get bigger.
And that leads us to maybe the most mind-bending question of all, one that's really pushing the boundaries of what we can even know. We've put together a pretty compelling story for how our universe began. But is it the only one out there? The idea of a multiverse isn't just for comic books anymore. It's a serious question for physics, and it just shows you how much more there is left to explore. Thanks for digging into all this with me.